Hi guys, hope you are doing good. Uh, okay, today I'm going to do chapter 8.2, which is confidence intervals for one population mean when sigma is known. This is really important when sigma is known. What is sigma? Standard deviation. Okay, there are a few things you should know before we go into this section. Uh, this interval procedure we use C table for our calculations. We use C table to find. Our purpose is to find confidence interval. Remember that this is our goal, to find the confidence interval for population mean mu. Population mean mu. First of all, we do some assumptions like always our sample is simple random sample, so you don't need to worry about that too much. Always you have been given simple random sample, and also we have large enough sample, or we know that our population is normal distributed. And the last one is very important, sigma is known. Okay, so you have to stick with these three, which mean simply keep these three in your mind. These are the assumptions. So in any case, you should, or your problem should satisfy these three assumptions, so that simply you can apply this procedure. Okay okay it is easy. There are only three steps. Okay, first one, for confidence interval, they will give you what is your confidence interval, so that you can calculate 1 minus alpha. I think you may remember this alpha. Okay, how do you find this alpha? Do you know what is the relationship between confidence level and alpha, right? 1 minus confidence level equals alpha. Okay, which mean 1 minus alpha equals confidence level. How you calculate the confidence level? Okay, confidence level mean uh, confidence level mean confidence interval divided by 100, right? Because confidence interval always percentage, so when you divide that by 100 you can get the confidence level. Confidence level is just a decimal number, 0 point something. Okay, so you can calculate your alpha, then using C table to find this guy, C alpha over 2. C alpha over 2. Okay, how we calculate C alpha over 2? Okay, we will see next slide. Okay, first step is done. So you have calculated C alpha over 2. Okay, next step, you need to calculate your goal, which is calculate the confidence interval CI. Simply say CI for what? For mu. So this is the form you need to use. X bar, which is your mean, plus or minus C alpha. This is the part to have calculated from first step. Sigma over times sigma over square root of n. What is this sigma? Standard deviation. You know that. We assume you know this value. You know this value. So using that, you can calculate 1 minus alpha percent confidence interval, which means your problem, this is your problem, is x bar minus this piece, C alpha over 2 times sigma over square root of n, comma, x bar plus this piece. This left side, x bar minus this piece gives you lower bound, and x bar plus This part gives you upper bound. Got it? So this is your confidence interval. Okay, last step. So step 2 is done. So last step is interpret the results. So how do you interpret the confidence interval, which means the results you got from step 2? Confidence interval is exact for normal populations and it's approximately correct for the last sample from non-normal population. These results what you got from step 2 is true under these assumptions. Confidence interval is exact for normal population. Okay. Or if I have approximately normal distribution, which means large enough sample, so that this results are true. So anyway, you have to stick with these first and second steps. Okay, let's see how we calculate this stuff. First, you need C alpha over 2, this guy, by using your standard normal table. How we get that? Your confidence interval, they will give you. In last case, they gave you it is 95% something, right? They haven't. Sorry, last time they haven't given you, but in general they will give you 95% confidence interval. So just focus on this value 95%. You know what's the relationship between confidence level and alpha? Confidence level mean 1 minus alpha, which means alpha equals 1 minus confidence level. This is your confidence level. This is your alpha. So 1 minus confidence level is your alpha. Here alpha is 0.05. Remember, confidence interval, convert to decimal to get the confidence level. Okay, then you have 0.05. Now you know what is alpha. You can calculate C alpha over 2 as usual. What something we have done in chapter 6. C alpha over 2. How we calculate the C value or this standard normal value? C alpha. Alpha equals 0.05 like this 0.05 divide by 2. Definitely you have to divide alpha by 2. Please don't simply replace this just alpha without having this 2. C alpha over 2, which means C 0.025. So this is the value. You need to figure it out from your C table. Get the this is the value. So C table is something like this. Locate this value 0.025. Get the row value and get the column value. So it when you collect those two values, you will get the C value regarding this 0.025 is 1.96. Okay, I assume that uh, you know how to find C values from chapter 6. If you don't remember, please go to chapter 6 and make sure you know how to find the C values. Okay, now step 1 is done, so you can calculate that values. uh, anyway, there are few things they have mentioned actually. uh, when to use one mean C interval procedure for a small sample. For a small samples, remember this: if your sample is less than 50, less than 15, less than 15, uh, you can use this procedure if your consideration is normal distributed or very close, simply normal distributed. For samples something moderate sizes like between 15 and 30, again you can use this unless you have outliers. You know what is the outliers? Okay, unless you have outliers, you can use this procedure. Okay, for large samples, I don't think uh, it's a problem. For large cases, something like sample size 30 or more, you can simply approximate your sample like normal distributed, then use C intervals. Okay, and in that case, if you have outliers, simply you can uh, forget about that outliers if they do not harm into your calculations. Okay, if it's like this: if outliers are present but their removal is justified and results in data set for which C interval procedure is appropriate. Okay, so if those values uh, do not harm for your calculations, you can simply remove your outliers. So but in this case, in our cases, don't worry too much about these sample sizes. Okay, most of the time you will see you have large enough samples. If you not, you will see it is normal distributed already. Okay, so just keep this in your mind when you are using these procedures. Whenever you use procedure, this procedure what you have learned, make sure these few things. Okay, okay. There is a fundamental principle of this kind of analysis. Uh, it is this: if whenever you use this procedure what you have learned, you should make sure that your case satisfy all the conditions what we are talking in this section. Okay, first, assumptions as well as the procedure as well as the conditions what we talked about here. Okay, if you feel no, they violate sometimes these conditions violate in my case, so that please do not apply this procedure. Okay, they are not valid anymore. Okay, okay, let's see one few examples. Okay, here you have data 50 data in here. It's not 30, it is 50. Sorry for that. Okay, you have 50 random selected people. What we need to find 95% confidence interval for mean age mu. They have given sigma, so we are working under non sigma. Okay, how we do this? Three steps, easy. For confidence level 1 minus alpha, so you know this is 95%, which means your confidence level is 0.95. So you can simply calculate your alpha gonna be what, 0.05. So now you can calculate C alpha over 2. Alpha is 0.05, alpha over 2 is what, 0.25. So C 0.025 is 1.96 using C table. Next step number 2, confidence interval for mu is from this form. You can calculate, you know what is x bar. Actually you have to calculate that. C alpha over 2, you just figure it out. You know what is sigma over square root of n. They have given sigma, so you can calculate that. So plus, using plus minus, you can get the lower value and upper value. Okay, sigma given, n given. From step 1, you know what is this, C alpha over 2. Then what, compute x bar. It is easy. Sigma xi over n. Sigma xi is 1119 divided by 50. So x bar is this, 36.4. So 95% confidence interval for mu is x bar minus this stuff, C alpha over 2 times sigma over square root of n. So you can calculate this value like 33 to 39.8. Okay, so CI, confidence interval, CI confidence interval, done. Now step number 3, you should interpret this. Okay, you should say, okay, these are my results. 95 confidence, we are 95 confident that mean age mu, that's what we are talking about, of all people in the civilian labor force is somewhere between these two values, 33 years and 39.8 years. Okay, these values you took from your calculations, and rest of thing you got from your question. So your story from here, it can be changed according to your problem. Okay, this is a complete answer, which means this is how we deal with this kind of confidence interval in real world as well. Okay, okay. I think there is another example. I'm not going to through this step by step. Just focus on the question. We have 36 new homes, which means your n equal 36. Okay, they have given you what you need to find actually. See, calculate the 95.44% confidence interval from you. This is your question. Don't worry about this value. This can be any value. That's okay. This is your confidence interval. You need to find for confidence interval for mu when, okay, sigma given, no problem, and they have given, okay, assuming it's normal distributed. Okay, then you have to follow those steps. First find first calculate c alpha over 2, or simply you can calculate x bar, what is the mean and this value, because you need that value. uh, Forget about this one, just focus on this one, this value, because c alpha over 2 multiplied by uh, this sigma over square root of n, right? Sigma over square root of n. This is what you have learned in step 2, I guess. Okay. Oh, sorry. Okay. Uh, you can calculate CI, confidence interval, by using this equation. This means you don't need to worry about this value. This is this value. Okay. This is simply this value. Uh, Regarding to 95.44%. So you can calculate alpha. What is alpha? 1 minus confidence level. Okay, 1 minus confidence level. So alpha gonna be uh what is this? Alpha gonna be 1 minus 0.9544. Okay, so here you can calculate the alpha. Okay, alpha, c alpha divided by 2, c alpha divided by 2 here, that value gonna be 0.0228. So according to this value you can calculate the c value. It is 2. C alpha times sigma x bar, or this value 1.2, it is 2.4. Now you can calculate according to your formula, x bar minus that piece or x bar plus that piece. So x bar minus 2.4 is this much, x bar plus 2.4 is this much. So the 95.44% confidence interval for mu is 63,430 and 68,230. Okay, you can simply say that we are 95% confident that the mean annual price, according to your question, for mu is between these two values. Okay, this is something I just need to give you rough idea. If you consider each confidence interval, they are within the confidence interval range. Give me 1 second and I just need to check the values. This is 63, 68. So 63, 68. So you had your values in between this interval, in between these values. Okay, so you can check each of these confidence interval, this confidence interval in between your confidence interval which you just calculated. Okay, see these values. For an example, this one 62 and 66, these two values in between these values or inside this interval. Okay, but you see here in this case it's not inside your interval, it is somewhere here. Okay, upper bound is somewhere here, that's why it is not in the interval. Okay, it's just to get a rough idea how we deals with this kind of guys. Okay, okay, there is another example, but this example they haven't given any specific information. Just give you sample size, simple n equal 35, and you have this table, you can calculate x bar. Okay, but step by step they answer, they need answers what they want. Then if you follow this part A, part B, part C, doesn't matter, you don't need to think too much. Okay, okay, you don't need to calculate summation, they have given summation. Okay, determine the point estimate. Okay, now we are trying to do something from the first place. Okay, start from the very beginning. You need to find the point estimate of what, for the mean fuel tank capacity. So you need to calculate x bar summation of xi over n, given this value, divided by 35. Got it. Okay, this is your mean point estimate for the mean fuel tank capacity of all new models. Okay, let's see next part. Determine, okay, 95 confidence interval for the mean fuel tank capacity, which mean for x bar. Okay, this is actually what we discussed so far. They have given sigma, so you can simply get this piece sigma over square root of n, this part. Okay, so we can calculate c alpha. Here alpha is 0.05, can calculate that, right? Divide by 2, you can get this, and c value you can calculate this guy. Now you know what is this, c times this value, it becomes 9.19, sorry, 1.96, multiplied by this value you got from here. Okay, this is the value. So x bar minus that value, x bar plus that value, easily you can get those two values, and you can say, okay, 95 confidence interval for mu, for mu, or you can replace mu mean, mean fuel tank capacity of all new mobiles, or all new automobile models would be from these two values. Okay, part C they ask, okay, this is something important. How would you decide whether fuel tank capacity for new automobile models are approximately normally distributed? How? Easy. Check what is the sample size n. It is what? I don't remember the value. N is 35. So n is 35. Easy. So that sample size greater than 30. You know what's the answer, right? It is, if it is greater than 30, we can approximate it to normally distributed. Okay. Okay. Uh, this is the last thing we need to learn from this chapter. Last time I told you something like we can calculate the confidence interval by using point estimator. Sorry, let's say here point estimator plus or minus margin of error margin of error. Do you remember that in last chapter, chapter 8.1, we discussed something like this? Okay, here we go. Margin of error. Margin of error for the estimator mu. We can calculate it's using like this. Margin of error be denoted by capital E. So you can calculate C alpha over 2 times sigma over square root of n. I know that you are very familiar with this guy, right? Last few slides you calculated this guy. Yes, this is your margin of error. So you are familiar with this device. See, x bar, it is your point estimator, plus that margin of error minus that margin of error. See, you have calculated this guy before, right? Confidence interval, comma, this value, lower bound, upper bound, right? This is what we have done so far in this chapter. So this part here is your margin of error, capital E, margin of error. Okay. uh, Again, there is what we call relationship between length and margin of error. This is your margin of error and length. How you calculate the length? Length mean upper bound minus lower bound. That's we call length. Length of CI is upper bound minus lower bound. So you know what is the upper bound? C x bar plus C alpha over 2 times sigma over n, sigma over square root of n. Lower bound is minus x bar minus this minus x bar minus C alpha over 2 times sigma over square root of n. So this gives you 2 times E, which means length equals 2 times margin of error. 2 times. Okay. So if you need to get the margin of error, please make sure that you are taking length divided by 2. Okay. So this is your margin of error E. This is the equation, and this is what it says. Margin of error equals length divided by 2. Okay, we will see that. In this case, I'm not going to do this age of 50 people. So there are 50 people, 95 confidence interval for mu. Okay, go through this process. You know how to find C alpha over 2, n given, sigma given, x bar given. Okay, you can calculate the confidence interval using this form. Okay, these are the confidence interval values, right? Make sure pause this video and do these calculations. Okay, now see 33, 39. So 33, 39. So these are the values, right? Okay. X bar, what is the x bar? X bar 36.4. So gap between these two values are 3.4, right? So this is x bar plus 3.4, and this is x bar minus 3.4, right? Clear? So this is x bar minus, this is x bar plus. I'm so sorry about this. This should be minus. Okay, it should be minus. Clear? Okay. When you need to find margin of error using lower bound, upper bound, make sure that gap divide by 2. Okay, here they have found it. Margin of error length divide by 2, 7.8. Okay. That is the one thing just you need to know. Present of fact, x bar is the estimate of mu. Margin of error determined by margin of error. Why? because we found this guy, we found the confidence interval for this guy, x bar plus or minus, do you remember that equation, C alpha over 2 times sigma over square root of n. This part we call capital E, right? Margin of error. So we determine that by using margin of error. When you fix the confidence interval, when you fix the confidence level, okay, which means you can fix the alpha, okay. Although you increase this sample size, this E, it doesn't change, okay, it remains same because you fix this alpha. Simply you fix confidence level 1 minus alpha, okay. When you fix 1 minus alpha, then although you increase the sample size, E doesn't change, E remains same, E remain same, okay. So we call that improve the precision. When you increase the sample size, n goes up, E doesn't change, so precision increases, okay. Whenever you need to find the sample size according to given alpha value, you can use this equation. This n means sample size. Always you will be having a decimal number, so you can round it up, so no worry about that, because sample size, there is no sample size like 25.6, no, you have to round it up like 26, okay, whole number. C alpha over 2, this is the value you can calculate. You know what is 1 minus alpha, so no problem, you can get that value. E given, see, E is given, margin of error given, so you can calculate E. I think they have yeah, they have an example, they have given an example. uh, Sigma given, okay. E 95% confidence, so you can calculate alpha using this. Mu is within 0.5 years, which means your error is 0.5. Got it? Mu within 0.5. Mu mean x bar, this side. So this is 0.5. This is 0.5. So this is E, this is C. It doesn't matter you whether you consider negative side, positive side, whatever, it is 0.5. So plug those values into this equation, do some calculations, you will get this. Real value is n equal 2249.79. Just round it up. See, 2250. Okay. Uh, I think this is just a summary what we have done. I'm not going to do this again. This is something you have done. You just check this. Okay. This is how to find confidence interval. Okay. Uh, so that's all for today. I think you will get rough idea, at least rough idea. Please try to go through the materials once and make sure you have covered everything. Okay. Okay, guys, stay safe. See you next time.